Hello from Portland. I have a couple of interesting things going on today. I have some extra time because my son is starting an after-school science class on robotics, and there's no way that could go wrong. Also, tonight my friend Ted and I are going to go to what's called the Science Pub, which is a really great thing where scientists come and talk about different subjects, and you can listen to them talk about science and drink beer. So yay science and yay beer. This particular science pub is about adoption, and it sounds really interesting, and I think it may actually inspire a bunch of vlog posts later. But I've also decided I don't want this vlog to just be me talking, so I want to include conversations with other people. And I started last night with a good friend of mine who is now on his way to China. He's a mathematician and a really sweet guy, and we had an interesting conversation last night, and here's a little bit of it. Can we roll the clip? There's nobody there. I'd just like to act like I have people to tell to do things. Roll the clip. Over again. All right.
This is my good side, at least.
What?
So this is my good side.
I think all your sides are good sides. I think you're like a Mobius strip of adorable.
So I have one side.
Exactly. Exactly, and it's a good side. This is my friend Dr. Chuck Dunn, who is our resident mathematician. Because he is the only mathematician I know. Chuck is over here because he's about to leave on a lengthy trip to China. How is the math different in China? Are there different numbers?
Well, they used to use different symbols, yes. And we're going to be looking at the differences in how certain aspects in algebra were done in China compared to the West. And then we're going to go to Japan and look at geometry and compare that to how it's done in the West.
Now, how is Japanese geometry? I mean, I guess you don't know until you go there, but you must know it's different because you wouldn't want to go all the way over there and then discover
there's more attention
triangles.
paid to the aesthetic of something, like the beauty of it.
Okay, now I'm just going to throw this out, and this may be just horribly stereotypical, but I actually read, I think it was a Malcolm Gladwell book, but it was talking about how cultures that grow rice have more sophisticated math because they have to count grains of rice.
Well, a lot of the problems that we're going to be doing, which are from, like 2,500 years ago to a couple hundred years ago, do involve rice.
So that wasn't just horribly racist on my part. That
No,
there's actually some.
I don't know if it's
validity.
Well, and then they proved a lot of results before they were proven in the West, even though the West gets the credit for them. So
You must know some secret numbers.
Hang on.
We have now switched to my husband's iPad because I got up to answer the door and tripped over my camera wire and yanked out part of the camera that I think is fixable, but we'll see. So, this is Scott, who's Chuck's partner, who was somewhere else and is joining us here now. That's who was at the door. And now he's given. Scott teaches photography to high school students. And as you can see, he has excellent taste in hats. So we were talking about your favorite number.
Yeah.
What's your favorite mathematical concept? Let me make it easier than
Sure. So, when you said number, it made me think of numbers that are transcendental. Are you familiar with those?
No, but we're here to be educated.
Well, so most of the numbers that you're familiar with would be things like integers, like 1, 2, 3, 4, or negative integers, -1, -2. 1/2, those would be rational numbers. Irrational numbers, things like the square root of 2. But then there are numbers that are irrational, and irrational numbers can be put in two categories, those that are algebraic and those that are not algebraic. The non-algebraic ones are called transcendental numbers. But here's what the interesting thing is I don't know if you're familiar with the different sizes of infinity.
Yes, I'm familiar with it through fiction, not through actual math.
Well, it's actually true. So the real numbers, there are the algebraic numbers and the transcendental numbers. And almost every number you know is an algebraic number. Mm-hmm. But the interesting thing is the size of infinity is smaller for the algebraic numbers. So that means that if you were to randomly choose any real number right now, it's basically 100% probability. No, randomly. Like you don't get to choose which one. Oh, like you just imagine there being a big bowl of real numbers, and all of them are in there, and you pick one out. There's basically a 100% chance you're going to pick a transcendental number. Yet the only transcendental numbers I'm sure you're familiar with are maybe pi and e.
Oh, okay. So there's way more of the numbers I don't know.
So we study these things, yet we only know this infinitesimally small little slice. Isn't that interesting?
That goes beyond interesting. That is absolutely profound.